Hello everyone, today we are going to go over the Sticks and Stones problem solving method for counting. And our first problem, problem 8, is Alex has 10 $1 bills to distribute among the 5 members of Mu Alpha Theta. How many ways are there to distribute his money? So to solve this problem, let's draw out the 10 $1 bills. We have 1, 2, 3, 4, 5. 9, 10. So let's say these are 10 $1 bills and we want to distribute them among 5 members of Mu Alpha Theta. And so one way we can do this, and this is why we should draw a diagram at all times. I'm a huge fan of diagrams. Please do them in your homework sets. If we want to distribute them among the 5 members, we can use 4 sticks for that. 1, 2, 3, 4. So imagine that we put like a stick right here, and we put a stick right here, and we put a stick right here, another stick right here. Well, what this represents is that person A gets $2, person B gets $3, person C gets $3, person D gets no dollars, person E gets $2. And so this is using these sticks and these stones. It's a really effective method for solving this problem instead of just straight up counting. I would say that I'm not quite sure how you would solve this problem without using sticks and stones, because then you would have to, you have to consider how many different ways there are to add up to 5. You would have there's 1 plus 1 plus 1 plus 1 plus 1, and so everyone would get $1, and there's one way for that to happen. Or we could have 2 plus 1 plus 1 plus 1. And there's some number of ways for that to happen. Or they could have 3 plus 1 plus 1, and there's some number of ways for that to happen. But then you also have these situations like, you have 4 plus 2, or you have 3 plus 2, or you have there's just a lot of different ways you can split this up. And so this is really ineffective and inefficient actually when solving this problem. But because I've taught you this concept of sticks and stones, it'll be a lot easier if you visualize it in this way I meant. So to solve this problem using this kind of visualization method, you need to realize, there are 10 stones and 4 sticks, so there are 14 gaps. What I mean by gaps is that there are 14 places where we can put our sticks. So we would have 14 choose 4. And keep in mind that's equal to 14 choose 10. What this basically means is that we have 14 places, and we can put our 4 sticks in any of those 14 places. Well, then the rest will just naturally be filled up with the 10 stones or 10 pieces of $1 bills. So we just need to solve this right here. And solving this, that'll be 14 factorial divided by 10 factorial divided by 4 factorial. And that is equal to 14 times 13 times 12 times 11 divided by 4 times 3 times 2 times 1. 4 times 3 is equal to 12. And divide by 2, that's equal to 7. 13 times 11 is equal to 140. We had that 141, right? Then 141 times 7. Wait, shoot. 13 times 11 is equal to 3, right? 143. So 143 times 7 is equal to 1001. So there are 1001 ways that Alex could split up his money among the 6 members or 5 members of Mu Alpha Theta. Alright. Problem 9. How many ways are there to roll a sum of 7 with 3 standard 6-face dice? And so what you have now is, Well, I'm going to draw our stones first, and our stones are going to be represented as pebbles, and we're going to have 7 of these pebbles to represent the sum of 7. So we have 1, 2, 3, 4, 5, 6, 7 here. And then it's asking how many ways are there to roll a sum of 7 with 3 standard 6-faced dice. So there are a few conditions. 1, 3 dice. 2, each dice could have a value between 1 to 6. So what that means is that because there are 3 dice, we're going to have to divide this up into 3 portions. And to divide this up into 3 portions, we need 2 sticks. 2 sticks. And so this is a little bit different than the problem we did before because there's also this rule right here. Each stick or each portion has to have at least a value of 1. Whereas before, 2 sticks could be next to each other, right? 2 sticks could be next to each other, denoting that this value is 0. That's not possible in this case. There has to be a stone between each stick, at least a stone between each stick. So that means for this problem, there are only 1, 2, 3, 4, 5, 6. There are only 6 places that these sticks could go to. So our problem would be 6 to choose 2. And that is equal to 6 factorial divided by 4 factorial divided by 2 factorial, which is equal to 6 times 5 divided by 6 times 5 divided by 2, which is equal to 3 times 5, which is equal to 15 situations total. Alright. You could pause the video right now and try to understand how this problem is different from the problem before because of this restriction right here. The value has to be between 1 and 6, so 2 sticks cannot be together. And then there are only 6 spaces now. Alright, our next problem, problem 10. Each of the numbers 1 through 10 is placed in a bag and drawn at random with replacement. How many ways can 3 numbers be drawn whose sum is 13? Well, this is a lot like the problem we did in problem 9. We're trying to get a sum of 13, so I'm going to draw 13 pebbles. 1, 2, 3. 11, 12, 13. So these are 13 pebbles, and we have to draw 3 numbers total, which means we're going to have 2 sticks. And then, so the problem should be straightforward like the one we did before. Well, we would just have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 gaps. And then we want to choose 2 of those gaps to put our sticks in. And we're going to see how many total ways are there to do that. But the problem with this the problem with this straightforward method is that we also have another limitation in our problem. And so that problem is that, well, before, the number has to be between 1 to 6, right? In this case, the number is between 1 to 10. So what that means is that certain situations are not possible. And so those certain situations include, well, let me erase all these sticks. This situation right here is not possible because that means that the first roll, or the first drawing of the number, we got 11. Second drawing we got 1, and third drawing we got 1. But it's not possible to get 11. So this is one situation that's not possible. And so this is not possible. That also means that the reverse or the opposite of this is not possible. If we put the 2 sticks here, this is not possible because on our third drawing we would get 11, and we can't get 11. We have to get between 1 and 10. So this is not possible. And then the third situation that's not possible is if we have our sticks right here. It's because that would mean that in the second drawing we got 11, and again that's not possible. So our equation now is actually 12 choose 2 minus 3 specific situations that are not possible. So 12 choose 2 would be 12 factorial divided by 10 factorial divided by 2 factorial. So that's equal to 12 times 11 times 2 times 1 divided by 2. That's equal to 6. That's equal to 66. And 66 minus 3 is equal to 63. So there are 63 different ways that we could get a sum of 13 if we participated in this game. Sticks and stones is a very powerful method for counting. Just, thank you guys for listening and watching. I just realized something weird. Okay, yeah, sticks and stones is a powerful method you can use to solve these sorts of problems. Try to understand how we redefine the situation in order to make counting it easier. And I will see you guys next week.